Good morning, ma'am. Good morning, classmates. So, our topic for today is all about the Nano World. So, introduction. The scientific researchers have developed new technological tools that greatly improve different aspects of our lives. The use of nanoscale is one of the important interdisciplinary areas generated by in science and technology. Scientists, engineers, will able to build innovative properties as they manipulate by nanomaterials. So dito sa report ko, matatakol natin kung gaano nga ba kaliit ang isang nanoscale, kung ano nga ba ang nanomanufacturing, nanotechnology at nanoscience, at ano yung mga government na nagpa-fund sa mga nanotechnology. And last but not least is yung mga benefits ng nanotechnology. So, how small the nanoscale? Gaano nga ba kaliit ang isang nanomaterial? So, sabi dito, a nanometer is a billion of a meter. So, in the international system of units, the prefix nano means 1 billion or 10 raised to negative 9. Therefore, yung isang nanometer, it is a 1 billion of a meter. So, it is very difficult to imagine kung gaano kaliit ang isang nanomaterial o nano. So, here is dito, example to kung gaano ba natin or gaano pa kaliit ang isang nanomaterial or nanoparticle. So, sabi dito, if a nanomaterial was the size of a football, then yung virus na napakaliit would be as big as a person. So, kapag i-compare mo ang isang football at isang person, may kita sa sizes nila na napakaliit at sobrang liit ng nanoparticle. So, sabi dito ulit, a red blood cell would be the size of a rugby field, a donut would be as big as a New Zealand, and the kiwi would be as big as the world. So, may kita mo pa lang sa differences ng mga differences ng sizes, may kita dito na napakaliit ng isang nanoparticle. So, here are some more examples. So, yung one sheet of paper daw is about 100,000 nanometers thick. Yung strand daw ng human DNA is 2.5 nanometers in diameters. And sabi din dito, there are 25,400,000 nanometers in a 1 inch. Sa isang 1 inch daw, merong 25,400,000 nanometers. So, imagine, napakaliit ng isang nanoparticles. Isa pa is, so yung human hair daw, it is approximately 80,000 and 80,000 to 100,000 nanometers wide. And lastly, 1 nanometer daw, yung kung gaano daw kumahaba yung fingernails natin sa isang segundo. So, imagine, napakaliit nito na hindi natin makita with our naked eye. So, nanoscale. Nanoscale is a peer-reviewed scientific journal covering experimental and theoretical research in all areas of nanotechnology and nanoscience. It is published by the Royal Society of Chemistry. According to the journal citation reports, the journal has 2020 impact factor of 7.790. So, kapag sinabi natin kasi in peer-reviewed journals, ito yung mga articles na sinulat ng mga experts and nireview ng mga several other experts. So, when we say nanotechnology kasi, it is the ability to design, to manipulate, and nagmamanufacture sa mga materials. And when we say materials na to, it is called the nanomaterials. And kapag sinabi namang nanoscience, ito yung study ng nano. So, where are nanomaterials found? Saan nga ba natin nakikita ang mga nanomaterials? So, yung nanomaterials, it is all around us. So, makikita natin to or nag-exist to in nature and in our life environment. Pero sabi nga dito, some nanomaterials can occur naturally. So, katulad nung mga essential protein na dala-dala ng dugo natin, yung mga lipids na matatagpuan sa dugo, and mga body fats natin. So dito, scientists, however, are particularly interested in engineered nanomaterials or ENMS. So ano nga ba ang engineered nanomaterial or ENMS? Engineered nanomaterials, it is ito yung mga chemical substances or materials that are engineered with particle sizes. So ito yung mga minamanufactured using ENMS. These are sunscreens, cosmetics, sporting goods, stain-resistant coating, tires, electronics. So they are also in medical diagnosis. Next. So what kind of microscope can see nanomaterials? So na-explain ko naman kanina kung gaano kaliit ang isang nanomaterials. Na most nanomaterials are too small na hindi natin makikita with our naked eye, and even yung mga ibang conventional light microscope. So itong transmission electron microscope daw ginagamit para makita ang isang makita ang isang nanoparticles and atoms. So etong transmission electron microscope can magnify daw or can be used to magnify things over 500 times, enough to see lots of details inside the cells. So ito po yung example ng transmission electron microscope. Ito po. So next is dumako naman po tayo sa nanomanufacturing. So ano nga ba ang nanomanufacturing? So it refers to scaled up, reliable, and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. It involves research, improvement, and incorporation of processes for the construction of materials. So kapag sinabi natin nanomanufacturing, it is the production of nanoscale materials. So involved rito yung pangmalakasan at pagre-research, improvement, and incorporation of processes para makakonstruct ng materials. So in manufacturing, products can be developed from two basic approaches. These are the bottom-up fabrication and the top-down fabrication. So bottom-up fabrication, it manufactures products by building them up from atomic and molecular scale components. Scientists and engineers are still in search for effective ways of putting up together molecular components that self-assemble and from the bottom up to organize structures. So kapag sinabi natin bottom-up fabrication, it is the process of building products from molecular components. So example dito yung project, pag may ginawa kang project dito, this sort tend to be time consuming. So bakit time consuming? Kasi there are lot of elements na kailangan para maka-create ng given product. While itong top-down fabrication naman, it trims down larger pieces of material into nanoscale. This process need larger amounts of materials and discards excess raw materials. Kung yung bottom-up fabrication, it is the process of building products. Yung top-down naman po, it is the process of developing products. So from whole pieces of material, such as examples is yung woods na kinakarve. Though mas straightforward yung bottom-up approach, itong method naman na to can be more wasteful. If yung bottom-up ay time-consuming, etong top-down naman is very wasteful. Why? Kasi, for example nga yung sa woods, kapag nagka-carve ka, di ba maraming excess na raw materials na naaalis. So, yun, naiiwan lang yun sa floor sa cutting room, and para magkaroon ng shape yung final product. Nagets niyo po ba? So maraming nasasayang. Next is new approaches to the assembly of nanomaterials based from the application of principles. First is yung deep pen lithography. So it is a method which the tip of an atomic force microscope is dipped into chemical fluid and then utilized to write on a surface like an old-fashioned ink pen onto a paper. So it is a nanofabrication technique that can be used to directly write molecular patterns on substrate with high resolution and registration. So sabi dito, over the past 2 decades daw, yung DPN, nag-evolve daw ito in its ability to transport molecular and material inks. Ano nga ba yung mga material inks? So, it is like the biological molecules like DNA, virus, and proteins, and nanoparticles. So, nag-evolve daw yung ability nito na mag-transport ng material inks into many surfaces. So, yung tip down ng pen, it is coated with the molecule or the material-based ink. Tapos, water forms between the scanning probe tip to transfer the ink to the paper. So, kung matatandaan nyo, yung dating old-fashioned ink pen nga, diba? Ididip pa natin siya. Tapos, bago tayo makapagsulat. Nagigets nyo po ba? So, yung self-assembly. So, it depicts an approach wherein a set of components joined together to mold an organized structure in the absence of an outside directions. So, from the word itself, self-assembly. So, from the word itself, no, it assemble. So, yung mga set of components nag-assemble together. Wherein, yung mga components nag-join together o nag-assemble siya para mag-mold at para makapag-organize ng isang structure. So, next is chemical vapor deposition. It is a procedure wherein chemicals act in response to from very pure high-performance film. Itong chemical vapor deposition, it is a process whereby a solid material is deposited from a vapor by a chemical reaction occurring on or in the vicinity of a normally heated substrate surface. So, for example dito, yung powder or yung single crystal, gagawin mo ito or magiging solid material. So, from powder into solid material. Next is nano-imprint lithography. It is method of generating nanoscale attributes by stamping or printing them onto a surface. So, lahat naman tayo siguro familiar sa pag-i-stamp or pag-print, diba? So, parang ganito lang din ang nano-imprint lithography. So, mag-stamp ka lang or pag-print ka lang din into a surface. So, next is molecular beam epitaxy. So, it is one manner for depositing extremely controlled thin films. So, kapag sinabi natin molecular beam epitaxy, it is widely used, it is one of the manner for depositing extremely controlled thin film. So, it is widely used in the manufacture of semiconductor devices, including transistors. So, ano nga ba yung semiconductor? So, kapag sinabi kasi natin semiconductor, ito yung mga karaniwang may kita sa halos lahat na electronic devices. So, example ng semiconductor is silicon. So, yung silicon, ito yung karaniwang ginagamit sa computer or anumang electronic devices. And ito yung pinaka-considered na pinaka-the best na semiconductor. So, etong semiconductor device, itong MBE daw, or molecular beam epitaxy, ito yung ginagamit sa pagmamanufacture ng semiconductor devices, including transistor. And it is considered one of the most fundamental tools for the development of nanotechnologies. So next is roll-to-roll processing. It is a high-volume practice for constructing nanoscale devices on a roll of ultra-thin plastic or metal. So, kung yung iba, it is a rolled substrate in unrolled to undergo. So, kung yung iba is pag-stamp, pag-print, ano pa ba? Pagiging from powder to solid material, ganon, pang ididip mo, then ganun. Atong roll naman, ito yung processes or nag-undergo ng processing, pagko-coat or paglalaminate. Next, so ito yung product sa manufacturing. So isipin niyo yung yung nanoparticles magiging ganito through nano manufacturing. So a 16 gauge wire approximately 1.3 millimeters in diameter made from carbon nanotubes that were SPHN into thread and the same wire on a 150 ply spool. So next is government funding for nanotechnology in different countries, Diary 2005. So ito yung mga government na nagpo-fund sa nanotechnology sa iba't ibang bansa. So first is, ano muna ang nanotechnology? So nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. So nasabi ko nga kanina na ang nanotechnology relies on the ability to design, manipulate, and nagmamanufacture ng materials at the nanoscale. So, ano nga ba itong materials na to? So, these materials are called nanomaterials. So, yung father of nanotechnology daw, it is no other than physicist Richard Feynman. So, nanoscience and nanotechnology. So, kapag sinabi ko kanina, kapag sinabi natin nanoscience, ito yung study, while yung nanotechnology, ito yung application sa mga maliliit na bagay that we can use sa lahat ng branches ng science or in all other science fields such as chemistry, biology, physics, material science, and engineering. So first na government na nagpo-fund sa nanotechnology is the NNI, US National Nanotechnology Initiative. So this is the best known and most funded program of the United States. So the NNI was established in 2001 to coordinate US federal nanotechnology R&D. The NNI budget is 2008 and 2009 were $1.4 billion and $1.5 billion respectively. Next is EC or the European Commission. So in February 2008, the EC officially launched the European Nanoelectronics Initiative Advisory Council or ENIAC. So next is Japan or Nanotechnology Research Institute under the National Institute for Advanced Industrial Science and Technology or AIST. Next is yung sa Taiwan. So Taiwan, ang tawag dito is Taiwan National Science and Technology Program for Nanoscience and Nanotechnology. Fifth is yung sa India, Nanotechnology Research and Education Foundation. Next, China, National Center for Nanoscience and Technology. So National Center for Nanoscience and Technology, China, NST, established in December 2003. So it is co-founded by the Chinese Academy of Sciences or CAS and the Ministry of Education as an institution dedicated to fundamental and applied researches in the field of nanoscience and technology, especially those with important potential applications. NCNST is operated under the supervision of the governing board and aims to become a world-class research center as well as public technological platform and young talent training center in the field and to act as an important bridge for international academic exchange and collaboration. Next is Israel. Israel National Technology Initiative. So the INNI was funded as a shared initiative of Israel's Forum for National Infrastructure for Research and Development and Israel's Ministry of Economy. So yung main aim daw nito is to make a nanotechnology that the next wave of successful industry in Israel by creating an engine for global leadership. So next is Australia. Australia Office of Nanotechnology. So the nanotechnology field is one of the fastest growing areas of research and technology. So the Australian Nanotechnology Network, ANN, formerly ARCNN, is dedicated to substantially enhancing Australia's research outcomes in this important field by promoting effective collaboration, exposing researchers to alternative and complementary approaches from other fields, encouraging forums for postgraduate students and early career researchers, increasing nanotechnology infrastructure, enhancing awareness of existing infrastructure, and promoting international links. So the ANN will achieve these goals through its dedication to bringing together all the various groups working in the field of nanotechnology and related areas within Australia. Next is Canada. So National Institute of Nanotechnology in NINT. So it is the National Institute for Nanotechnology and NIT at the University of Alberta in Edmonton is dedicated to research in physics, chemistry, engineering, biology, informatics, pharmacy, and medicine. So it is established in 2001 and is operated as the partnership between the university and the National Research Council of Canada. Next is South Korea, Korean National Nanotechnology Initiative. So the initiative is now on its third phase, 2011 to 2020, with focus on clean nanotech. Korean National Nanotechnology Initiative, the Korean National Nanotechnology, was started in December 2000 by the National Science and Technology Council, and the NT Development Plan was approved by the NSTC in July 2001. Thailand, National Nanotechnology Center or Nanotech. So National Nanotechnology Center or Nanotech is a governmental organization under the National Science and Technology Development Agency, NSTDA, the Ministry of Higher Education, Science, Research and Innovation, MESI, which was established on August 13, 2003. So the main mission of the center is to build, support, and promote the benefits of nanotechnology as well as to disseminate nanotechnology-based knowledge to Thai society. So last but not the least is Malaysia. So National Malaysia Nanotechnology Initiative or NNI. So the organizing committee of Nanotech Malaysia 2009, including the Dr. Maximus Trinity Ongkil, Professor Burhanuddin Yup Majilis, Prof. Halimaton Hamdan, and Prof. ILC Kebe Shubur. So dumako naman po tayo sa specific nanomaterials and advanced technology. So developing nanomaterials that have special features and which focuses on specific application areas such as textile and household products, including the use of natural resources, improving quality life. So dito, dinidevelop yung mga nanomaterials na may special features which focuses sa mga textile na household products, kasama na rin yung mga natural resources to improve quality of life. So next is nanotechnology for agriculture and environment. So research and development of innovative food, agriculture, and environment with the application of nanotechnology to modify structures and surfaces, including the preparation of nanocomposite for strengthening economics and social operation, and promote environmental sustainability. So, yung nanotechnology daw is one of the promising technologies na makakapag-improve sa agricultural productivity via sa nano fertilizers, ginagamit use of efficient herbicides and pesticides, soil feature regulation, wastewater management, and pathogen detection. So, yung nanotechnology daw, nagpo-provide siya ng new agrochemical agents and new delivery mechanisms para mapa-improve yung crop productivity natin. Nasabi ko rin kanina na through nanotechnology, pwede natin ma-increase yung agricultural production natin and magkaroon ng ano bang tawag dito? Ng animal health, animal breeding, poultry productions. So, yung nanotechnology has many uses in all stages, no? So, kasama dito yung production, processing, pag-store, pagpapackage, and pagtransport ng mga agricultural products. So, next is nanotechnology for life and health. So, research and development of diagnostic tests using the nanotechnology for target molecules for development and new drug delivery system and benefit for cosmeceuticals from Thai medical herbs for health and medical applications. So, some of nanomaterials kasi or yung mga properties ng ibang nanomaterials, very ideal itong mga to para mapa-improve yung mga diagnosis at yung mga treatment sa mga diseases or cancer. So, bakit importante ang nanotechnology sa life and health natin? So, there has already been a great success in enhancing medication delivery with the nanotechnology. So, yung nano materials, they are able to attack cancer cells at without harming other healthy cells. So, some nanomaterials have also been used some of nanomaterials have also been used to enhance the pharmaceutical products like yung nasabi ko kanina, sunscreen and all. Next, nanometrology and engineering analysis. Research and development of metrology and safety aspects of nanotechnology, providing testing for nanoscale analysis, development of prototype, engineering research to create public confidence on nanoproducts and adhere to international standards and quality. So dito, nanotechnology, involved dito yung mga scientific and practical applications, so including yung health, agriculture, and especially dito is yung electronic devices, computer science, at marami pang other fields. So, nasabi ko nga kanina, yung mga computer, it plays an essential role sa life natin, especially and it is simulating and analyzing the features of nanoparticles. So, sabi ko nga kanina, yung semiconductor is through computer, meron siyang semiconductor or yung silicon na ginagamit. So, meron yun sa computer or ginagamit sa computers. So, development, design, structural materials, is the nanoscale via methods in calculation and computational chemistry, prototyping, pilot application, and field energy, and catalyst, sustainability, environmental friendly. So, possible applications of nanotechnology in the Philippines. So, one is ICT and semiconductors. So, ICT, information communication technology, or semiconductors. Semiconductors are substances with properties somewhere between them. ICs, integrated circuits, and electronic discrete components like diodes, transistor are made from semiconductors. So, common elemental semiconductor. So, bakit posibleng magkaroon ng nanotechnology here in the Philippines? So, kapag kasi natin sinabi nanotechnology, marami siyang naitutulong. So, eto nga, semiconductors, di ba? Nasabi ko kanina na ang semiconductors, semiconductor devices, including yung transistor, ito yung mga kinukonsider na mga fundamental tools para sa development ng nanotechnology. So, nasabi ko rin kanina yung example na semiconductor is yung silicon. So, saan nga ba nakikita ang semiconductor? So, natatagpuan nga ito sa mga halos lahat ng electronic devices natin. Yung silicon na example ng semiconductors, ginagamit ito sa computer or anumang electronic devices. And ito yung kinoconsidered na best semiconductor. Next is health and medicine. So, medicine and health encompasses the study of prevention, cure, and understanding of diseases, as well as the investigation of physical and mental well-being. Oxford Reference provides more than 82,000 concise definition in that. Specialist encyclopedic entries on the wide range of subjects within this discipline. So, dito sa health, so nasabi ko rin kanina na some properties ng mga nanomaterials is ginagamit or very ideal para mapa-improve yung mga diagnosis at saka treatments para sa mga diseases or cancers. So, nasabi ko rin kanina na yung mga nanomaterials, they are able to attack yung mga cancer cells selectively without harming the other healthy cells. So, next is energy. In physics, energy is the quantitative property that must be transferred to a body or physical system to perform work on the body or to heat it. Energy is a conserved quantity. The law of conservation of energy states that the energy can be converted in form, but not created or destroyed. So the unit of measurement, which is the energy transferred to an object by the work of moving in physics, energy is the quantitative property that must be transferred to a body of physical system to perform work on the body or to heat it. Energy is a conserved quantity. The law of conservation against the force of 1 Newton. So, dito sa energy, so ano nga bang kinalaman ng nanotechnology sa energy? So, nanotechnology, it is used to develop better batteries or ginagamit ito sa pagde-develop ng mga batteries such as yung mga lithium batteries na pwedeng magpa-improve ng energy density, charge and discharge efficiency, at saka yung cycle life. So, yung sa nanotechnology din, ginagamit to develop more durable, efficient fuel cells which can convert to hydrogen fuel into electricity. So, next, food and agriculture. The food and agriculture sector are almost entirely under private ownership and is composed of an estimated 2.1 million farms. So 935,000 restaurants and more than 200,000 registered food manufacturing, processing, and storage facilities. These sectors accounts are roughly 1/5 of the nation's economic activities. So, nasabi ko rin kanina dito, according sa Food and Agriculture, ang nanotechnology ay kayang mapa-improve yung crop productivity and through applying pesticides at saka yung mga fertilizers para sa improvement ng mga crops natin. So, nasabi ko rin kanina na ang nanotechnology is pwede din gamitin sa mga production, processing, pag-i-store, pagpa-package, at pagta-transport ng mga agricultural products natin. So, next is the environment. So, the natural environment or natural world encompasses all living and non-living things occurring naturally, meaning, in this case, not artificial. The term is most often applied to the earth and some parts of earth. This environment encompasses the interaction of all living species, climate, weather, and natural resources that affect human survival and economic activity. The concept of natural environment can be distinguished as components. So dito, sa environment, so ang nanotechnology, may potential ito or has the potential to play a significant role hindi lamang sa energy, sa medical field, sa agriculture, but also na rin sa environment. So, nagkakaroon ito ng protection and sustainability by enabling new and improved methods for monitoring, cleaning up, and mitigating environmental pollutants. So, pwede rin itong nakakatulong din ito para mag-reduce ng mga consumption and energy use through development and more efficient technologies. For example, so nanoparticles can be used to clean up oil spills, remediate contaminated soil and groundwater, and remove air pollutants. So yung mga nanotechnology din daw can also be used to create more efficient and effective method for solar energy capture and storage, as well as for producing biofuels from renewable resources. So overall, yung nanotechnology daw, it has the potential to make a positive impact sa environment natin and sustainability, pero it is essential to approach its development and application with caution and commitment to responsible use. So next is benefits and concerns of using nanotechnology. So nanotechnology has various application direct second environment, Salamanca, Buentello et al. 2005, proposed in an article addressing global challenges using nanotechnology and accelerate the use of nanotechnology to address critical sustainable development challenges. They suggested a model that could help figure out the possible contribution of the community in overcoming global challenges that pose risks on health and other aspects of people's lives. However, there are concerns that need to be addressed before promoting materials derived from a nanotechnology. So, sabi nga dito, yung nanotechnology daw, may mga beneficial applications, hindi lang sa medicine, sa environment, pero katulad ng mga ibang technologies or sa lahat ng technologies, may mga unintended effects din to that can adversely impact the environment, pati na rin sa human body and within our natural ecosystem. So while taking advantage of this new technology for health, environmental, and sustainability benefits, science needs to examine the environmental and health implications. So here are the benefits and the concerns of the applications of nanotechnology. So first is sa environment. So what are the possible benefits? So improved detections and removal of contaminants, development of industrial processes and materials. And yung mga concerns naman is yung high reactivity and toxicity, pervasive distribution in the environment, no nano-specific EPA regulations. Dito naman po sa health, possible benefits is yung improved medicine, concerns, ability to cross cell membranes and translocate in the body, no FDA approval needed for the cosmetics or supplements. So, sa economy naman, better products, new jobs. Then, sa concerns, redistribution of wealth, potential cost of cleanups and healthcare, accessibility to all income levels. So, sabi dito, nanotechnology is an advanced interdisciplinary field that encompasses and technology that manufactures materials of great help to the improvement of various areas of society, especially health, care, environment, energy, food, water, and agriculture. So, dito, nakita naman natin kung gaano kalaking tulong or gaano kalaki ng benefits sa mga improvements or para matulungan na mag-improve yung mga various areas ng society natin, katulad ng mga diniscuss ko kanina katulad sa yun nga, sa healthcare, sa environment, sa energy, sa agriculture, and etc. Yun lamang pat, maraming salamat.